exercise 130, question number 4. That's a required question on the BTEC course. So what I'll do is I'll run through one that's very similar and then leave you to have a go at this question yourself and check the answer in the textbook. So now we have two components, Z1 and Z2, in parallel. So here are the values for Z1 and Z2. Z1 has got a negative value, so that's a capacitive reactance, and Z2 positive, so that has an inductive element to it. These are put in parallel with a 240 volt supply. We have to find the total current flowing in the circuit, so that's the current here, and it's phased relative to the voltage. So the start point is the same as the previous question. I'm after the current, and that equals E over Z, where Z is the total impedance of the circuit. Again, I'm going to want the current in polar form, so once I get my values for E and for Z, T, I can convert them to polar and then do the polar division to end up with the current. This time, however, the two impedances are in parallel, so it's not quite so straightforward to find the total impedance. Just like for resistors in parallel, the total impedance is going to be the product, so Z1 times Z2, over the sum, Z1 plus Z2. But these are complex numbers, so I have to work out what Z1 times Z2 is and what Z1 plus Z2 is, and then convert them to polar, because I want it in polar eventually anyway, before I do the division, and then that will give me my solution for ZT. So let's run through this particular problem, then you can have a go yourself, but I'll go through the solution. So the first step is to find ZT then. So that's going to equal Z1 times Z2, so that's 20 minus 6J times 30 plus 2J over 20 minus 6J plus 30 plus 2J. So multiplying out the top brackets, I'm going to get 20 times 30 is 600. 20 times 2 is 40J. 6 3s 18, so it's 180J. Minus 6 times 2 is minus 12J squared over, adding real parts, 30 plus 20 is 50. And then imaginary parts, minus 6 plus 2 is minus 4J. So now collecting like terms and remembering that J squared is minus 1, I'm going to get 600 plus 12 is 612. Plus 40 minus 180 is minus 140J over 50 minus 4J. I could multiply top and bottom by complex conjugate of the bottom term, but as I want polar form anyway, let's just convert each of these to polar and then do the division. So I converted both of those numbers to polar form, and that gives you this answer. Worth noting at this point that here I've rounded that, and I've rounded this. I've rounded each of these figures to 2 or 3 significant figures, or 4 in one case. And then when I do the division, I'm going to round yet again. So there's lots of rounding going on here, and every time you do that, you introduce an error. So there is something to be said for doing the division in Cartesian form and holding all the accuracy, and then converting at the very end to get my polar answer. That will give me a more accurate answer that way. But carrying on with the solution, I'm now going to divide the moduli and subtract the angles. So 627.8 divided by 50.2 equals 12.5. and the angle is minus 12.9, minus is plus 4.6, which gives me minus 8.3 degrees. So that's my final solution. The current equals 12.5 amps, and it's lagging by 8.3 degrees. Now you have a go at the question in the textbook.